All right, so here's the diagram we have to work with, something we've seen before. We started kind of on this side. Remember the eutectic point we talked about? It's similar to an azeotrope in that it's just difficult to get around. So here we're going to explore ways to get around it. So first we're told that we do have a stream coming to this point, and that we are going to try to add some pure potassium to bring it to this side so that we can then separate out more, basically just shifting this over. So let's look at that equation. Say we mix equal parts. We get the fulcrum in the middle. We're told it's at 0 degrees Celsius, so we go up there. And then right away we should know we want to do the lever rule here. So we're also told it doesn't work. So let's see exactly why. So look at the flow rate. We can figure out from 4 and 3. Here's the total distance. Here's the distance for 4. You know that whole lever rule equation, something like that. So we can get these. How's this look so far? Joel says good. What? Oh, oops. Yeah, see, this should look obvious. If you had a seesaw right here and a giant mass, that would clearly be weighed down. I don't know if that ever happened to you in like first grade playground. But yeah, make sure this is an old tool. You don't want to like make silly mistakes like this. So just a quick reminder. Let's flip that out. We know we're actually supposed to use this side. Doesn't need to see me. Maybe we'll go over here. So here's the actual correct one, and then this looks like a little more balanced in there. So as we can see right here, never mind, I'm going to go on this side. As we see right here, we have 79 kilograms per minute coming in. Now, so stream 4 over there, must be more than the 100 kilograms that we supplied. So if we only have 79 coming out from here, but we said there was 100 going in here, that means that we're actually pumping in potassium over here. So not at all what we wanted. So this does not work. And then as some of you found, there are multiple ways to go about this. You can also look at it like a mass balance. If you draw your system borders around all your input and output streams, you know exactly what's coming in. We have 80 kilograms per minute potassium. We know because we read off at 0 degrees that this is the composition of potassium coming out the top. And we also, by doing the lever rule, know how much is coming out. So that comes out to 101 kilograms, which is way more than what we have coming in here. So that's another way to tell. And then you could also tell if you did like a full mass balance, even not considering this, with just like the sodium, that you could figure out that you'd have to have some kind of negative flow in here. But we can talk more about that later in part C. So then it asks you, can you change anything in this process to make it work? So one idea, since up here you have, you're kind of limited to this concentration of potassium or sodium, what if we lower this temperature down as low as we possibly can go? So then we can, get more of it to come this way, because that was our main problem. We only had 79 kilograms instead of 100 kilograms over here. And that was because this side is closer, it's a smaller lever. So if we repeat this, now that we've lengthened this side, we can get more over here. Do the exact same thing, figure all this out. Whoops. There. We figure out, once again, there's only 82 kilograms coming out. Helps a little bit, not much at all. We're still not getting the 100 that we wanted. So what did you all say? Did you say that there was some other way to make this better, to make this process work? Or no? No? Did anyone figure out a way to make it work? Because if you did, you should let us know. Nick?
Magic.
No?
Okay.
No? Okay.
Well, I thought we came close. We said if we raise the flow rate from 6 to 300.
Raise this to 300?
Yeah.
Okay, so it was closer. So if you raise that to 300, then you could, when you first mixed it, your fulcrum would shift over here. So yeah, let's talk about those sorts of options. If you decreased F6, so the flip side, you would move your fulcrum towards this side. So you would require less in here. So you'd have a smaller benchmark to meet over here. But now we see from this lever, we're barely going to get any pure K out. So that balance, if you go through the lever rule and everything, that's going to balance out again. And then what Nick suggested, you can move over here, increase that a lot, because now you're going to get a lot of pure K out of this balance here. But once again, because you're increasing this a lot, even though you're increasing this a lot, and this ends up still being larger if you do the same lever rule. You can't quite get over that boundary there. So either way, because of this point still being less than this point that fed into everything, you can't actually meet your quota coming out of stream 4. And another explanation that I think it was Aaron, I think you mentioned this. If you kind of do like a mass balance, like looking at this, you have a stream coming in here. If you just do a mass balance around the entire thing, you have streams coming out here and a stream coming out here. So so this is coming in, so this could be our fulcrum, and then this is what's coming out on either side. Both of the ends of our levers are to one side of our fulcrum. In that case, there's absolutely no way to balance that unless one of them is negative. So which is what we kept finding out. This always had to be going the other way because both children are on one side of the seesaw. It just doesn't work. So yeah, we can't find any way for this to work now. So then you could also do this if you're less visually inclined. Don't have to go through all of this. You can go through this stuff if you'd like. But this shows mathematically, kind of through the lever rules that we all did, how the flow rates of F6 and F4 compare. And yeah, so right here we just plug in from what we have in here. Keep going. Substitute for X and A. Go through it all and get that F4 is always smaller than F6. So we can never ever get enough potassium to come through here to meet what we want. So there's the mathematical approach and the graphical. Any questions on that? How the mass balance works out, phase diagram? No? Do we all get it? This is impossible? Cool. All right. Yeah.